Hello viewers, welcome again to Mathematics and I remain your presenter Jeff Nino, and today we shall be discussing the topic logarithm. Now if you remember on my previous videos I gave an explanation on how you can use laws of indices to solve problems on indices. So today we shall be looking at logarithm. Now first of all, logarithm will be treated in two ways. One, the one that involves formula, and then the one that involves four-figure table. But we shall be discussing the formula part today. So today we shall be introducing how you can use the laws in logarithm to solve problems. But first, you need to understand what's logarithm, how logarithm looks like. When you see a logarithm question, what do you see? Or you need to understand also how you can make use of these laws to solve problems. So when you hear logarithm, what comes to your mind? What do you see? What do you picture? Now, look up. If I have something like this, log x base y. Now, this x is called the number, and this y now is called the base. So this is pronounced log x to the base of y, or you can simply say log x base y. So it means when I have something like this, log 4, then I have 5. What does that mean? This is pronounced log 4 base 5. Or when I have log 3, 7, this is pronounced log 3 base 7. And then, what if I have log 2 without a base? Now, when there is no base, what base is there? Base 10. So this also means log 2 base 10. So when there is a base, you can pronounce when there is no base, the base is 10. Now, sometimes your number and your base can carry powers. Taking this form, log x raised to the power n base y raised to the power n. This is your number, like I said. This is your base, like I said. Now, both the number and the base now carries a power. Now, any form is counts. It doesn't really matter. What you now need to know is how can you use the laws to solve problems on logarithm. Now we shall be introducing laws of logarithm. Laws of logarithm. Okay, in today's video I shall be discussing 6 laws with you. 6 laws. Please listen and be blessed. Now the first law is called the addition law. The addition law. Now, how does it look like? Imagine we have something like this now. Log x plus log y. Now remember, I said this guy here is called the number. This guy here is also called the number. Now, what is the base? There is no base here. There is no base here. And I said, when there is no base, what base is there? Base 10. So what does that mean? It means the base here is 10 and the base here is 10. Now, because the base are the same, what do you do? Just like laws of indices. Because the base are the same, I will pick one of the log, one of them. Then I open a bracket. The number x times the number y. So now, x times y will give us log x, y. Now, let us use numbers to explain this law properly. So imagine we have log 4 plus log 3. Now, the base here is 10, the base here is 10. What will I do? I will just pick one of the log. Then, the first number here is 4, plus changes to times. The next number here is 3. Now, 4 times 3, will give us 12. So here becomes log 12. Applying the law. Addition becoming multiplication. Why is it multiplication? Because the bases are the same. When the bases are different, addition can never become multiplication. Now, taking us to law 2, which is called the subtraction law. Now, when you have something like this, log x minus log y. Now the same thing applies. The base, you must notice the base. That's the first thing you need to do as a student. When the log question is given to you, the first thing you look is the base. Are the base different or are the base the same? You must observe it. Now, because the base here is 10 and the base here is 10, the same thing. I'll pick one of the log and then I open a bracket. Now, my number here is x. Now, minus becomes division all over. Now, what's my number here? Y. So, this is it. So, using numbers to replace. So, we have something like this now. Log 4 minus log 2. So, what does that mean? Because the base are the same, I'll just come in. I'll pick one of the logs. Now, my first number here is 4. Minus becomes over. And my number here is 2. Now, 4 divided by 2 will give us 2. So, our final answer becomes log 2. Now, this is what? The second law. Now, going to the third law, which is called number to the same base. To the same base. Now, like this. Log x base x. Class, look up. We said this guy here is the number. This guy here is the base. Now, when you notice that the number and the base are the same, the answer becomes 1. You don't need to solve it. So, using numbers, it means if I have log 4 base 4, class, what's the answer? 1. Because the number and the base are the same. Now, this takes us to log 3. Now, without wasting time, let us take a look at log 4. Now, log 4 has a clean. I don't want to touch this part. Log 4 says log 4 says the number 1 to any base. Now, if I have something like this, log 1 base x, class, the answer is 0. When the number, mind you, when the number is 1 and the base is given to you, so far your number is 1, the answer is 0. So what does that mean? It means if I have something like this, log 1 base 4, the answer is 0. Or log 1 base 1000, the answer is 0. So far the number is 1, irrespective of the base. Now, without wasting time, log 5. Now, log 5, I will group into 2, but I call it the power law. I call it the power law. But I will be discussing it under 2 parts. Now, the A part. When the number carries a power. When the number, remember when you hear the number, I'm talking about this guy. When I say base, I'm talking about the guy down. Now, when this number carries a power, what do? Now, imagine we have something like this. Log x raised to power m base 1. Aha! This is my number. This is my base. Now, my number is carrying a power. How do you solve this? Simple. Here it comes. Watch me, class. The power goes back and becomes n log. Now, if the power is no more here, what do we have left here now? X base y. Simple. So now let us use number to replace this. Imagine I have something like this, class. Log 4 raised to power 2 base 4. Aha! Now, notice, the number is the one carrying the power. Like I said, m goes back. So what goes back? 2 goes back. So here becomes 2 log. What will now be left here now? 4 base 4. Now, remember the law that says number to the same base. When the number and the base are the same, what did I say is the answer? 1. So automatically, what do I have here? 2 brackets 1. How did I get this one? Number to the same base. The law. Now, what does brackets mean? Bracket means times. So what is 2 times 1, class? Our answer becomes 2. Now, this is the first part of power law. Now, let us go to the other part of power law. It is called the B part now. It is called when the base carries a power. When the base carries a power. Now, the one we just treated was when the number carries the power. What if now the base carries the power? How does it look like? Now we have something like this. Log x base y raised to the power n. Aha! Now, it is my base now carrying the power n. But do you know that x is also carrying a power? Yes, it is. If I have 4 raised to power 2, it means 4 is carrying power 2. But if I just have 4 without a power, class, what power is there? Power 1. So it means in this mass, x is also carrying a power, which is what? Power 1. So it means this is simply means log x raised to power 1 and then y raised to power n. Now, like we said, it is very simple. The power goes to the back. But now, because we have 2 powers here, now these 2 powers goes to the back and becomes a fraction. So here becomes, when this one way becomes 1 over, when n goes, it becomes n. Then what do we now have here, class? Log x base y. Now, how can we use numbers to replace this? Now imagine this, class. Watch me. If I have log 4 raised to power 3 base 4 raised to power 2. Aha! The number is carrying power 3. The base is carrying power 2. What happens? Both powers goes to the back and become a fraction. So here becomes 3 over 2 log, what we now have here now, 4 base 4. Now we said, when the number and the base are the same, what is the answer? 1. So what becomes here? 3 over 2 brackets 1. And what does brackets mean? Times. So 3 times 1 will give us 3 over 2. So that becomes the what? The answer. Now, the last law we shall be discussing is called, it's called the change of base. Change of base. Aha! Now imagine we have this log x base y, and now you are told to change this base. Change to base n. Now we are told naturally the original base is y, but now we are told to change to what? Base n. How do you solve this? Now, when you are changing this base y to base n, both the number will now be to the base of n and also the base also to the base of n. It's not look like this. Log x base y is equal to log x base n over log y base n over log y base n.